Here you go, ladies and gentlemen. So, I just want to remind you that you have a test on Monday. It's over 8.2 and 8.3, so just two sections. Which A3 not so bad. A2 is usually the toughie. Okay. So I'm teaching today and I'm teaching tomorrow. What will be the extra credit this weekend will be a review assignment for that, for that test. So check the class website, and basically all I'm going to do is, if you look at the homework assignment that I assigned, it was usually B's or A's or evens or odds, something like that, right? So I'm probably just going to be like, do the evens, do the odds. Like, I'll give you a selection of problems to do to narrow that down. But the idea is you've done half, so practice on the other half, okay? Extra practice. Yes, sir.
We need a book.
No, so I'll put all the photos up. And so I have been. How many of you have been checking the class website? Have you seen the photos and the link to the videos? And that's really important that you know how all of that works, okay? So if you haven't checked that out, please check out the class website. Change it to Good Now. And they post in two places, either announcements or classroom documents, okay? All right, so here we go. It's bloody hot in here. Example 1, factor out the common factor. Factor out the common factor.
We have a zero period.
But I can give you a little bit. So I put some Friday. Yeah, later. Oh, you agree? Oh, yeah. I got you. Oh, okay. So I learned last night that how was your so I'm like this good stuff. Yeah. I was like, it's just like an hour. Yeah, I sorry if ever watching YouTube. Alright, on letter A. The first question I'm going to ask you is, on letter A, how many terms do you see? 3 terms. Okay. So a term is an expression that's connected by multiplication. So this is, 4 times x cubed times y. It's all connected by multiplication. So this would be one term. They're separated by addition or subtraction. So here we have 12x squared y. That's another term. And then negative 16x is we get a third term. And I like to ask that question because if you can recognize a term, then factoring out the greatest common factor is much easier, okay? So when we look at those 3 terms, I'm going to ask you, well, what do they have in common? Okay, a 4. Could we take out the negative 4?
Yeah.
Yes, of course. If there's a leading negative, yeah, take out that leading negative. So I'm going to take out that leading negative. And I heard an x. All right, so negative 4x. Can we take out a y?
No.
No, how come I can't take out x cubed?
The last term doesn't have.
Yeah, this one only has a single x I can take out, not x times x times x. All right, so I can only take out the lowest power. Okay. Now you'll notice how I've written this. I've sort of written it as a division. So you don't have to write it this way. But really what I'm doing is undistributing. I'm undistributing. And undistributing. Sorry. All right. So So really what I'm doing when I factor out the common factor is we are undistributing it. Something had been multiplied through and we're going to bring it back in, reel it back in, out front. So I'm changing the form just a little bit. Now, I like to write it like this because I think it's easier to see how these things reduce. So how does this first term reduce? X squared y. Good. The 4 is reduced, and then one of those x's gets to come out. How does this middle term reduce? -3 xy squared. Good. And then how does this third term reduce? +4. Very good. Now there's nothing over here that I can combine. There's no like terms. And so this is our final answer. That's it. Now, same thing. Looks a lot different, right? Okay. So in general, looking at this particular question for letter B, how many terms do you see? For B, how many terms do you see? 2.
5.
2. No, so again, this is hard to figure out. But when I say a term is something connected through multiplication, so we have x squared times this entire group, that makes that one entire term, okay? And so here we have a -2 times this entire group, so that makes that a second entire term. And so not only can we factor out things like a number like 4 or x squared, but I can ask you now, looking at those 2 terms, what do they have in common? Yeah, I can factor out an entire bubble. I call this a bubble. It's like my favorite term. They have that same bubble. I'm going to undistribute that bubble, and we want to see what's left behind. Yeah, so you can see the x minus 5 reduces top and bottom, and we're left with x squared. And same thing over here, we're left with a -2. And we're done. Okay? So, any questions on those? All right, okay, that's not it. We got one. Okay. Okay. Example 2. Example 2. Factor the polynomial completely. Example 2. Factor the polynomial completely. Factor the polynomial completely. So today is a lot about patterns. And in the directions, I say GCF first. What's GCF stand for? Greatest common factor first. Always, always, always looking for the greatest common factor. When we're factoring, I think it's important to really understand what that means. So, my daughter's in 5th grade. Last year, 4th grade was all about multiplication and division. And so she was always answering questions like, what are the factors of 56? So what are the factors of 56? 7 and 8. Right, you know that. So yes, 7 and 8 and 1 and 56, sure. Okay, so 7 and 8, the reason they're called factors is because if you multiply them together, you would get 56. That's what factors mean. Things you can multiply together to get what you want. So that's what we're doing when we're looking at these expressions and trying to factor. We're trying to figure out what can we multiply together so that when we multiply, we get that expression. Okay? It's the same concept. Here I have this labeled difference of squares, but as it is, these are not difference of squares because they have a GCF. What do they have in common?
3x.
A 3x. So I'm going to factor out that 3x. I'm going to undistribute that 3x. And what's left behind?
9x squared and -4.
-4. Very good. Okay. So we factor out that greatest common factor, and now what we're left with is a special name. It's difference of squares. It's why is it called difference of squares?
Because two sets of equal plus or minus can make that. That makes sense.
Not at all. It didn't make any sense at all.
I already got it down.
So, okay, that's fabulous. Okay, so the
I'm the laughing stock of my table.
difference of squares is very literal. Mathematicians are not very creative. So difference of squares means we're subtracting, boom, perfect square numbers. Okay, and so what times what is 9x squared? 3x times 3x, yeah. And so that's a perfect square. And then what times what is 4? 2 and 2, yeah. So it's of the form a squared minus b squared. This is difference of perfect squares. And I bet you all know how to factor that. The very easy way that I factor everything is to ask myself, what times what is 9x squared? 3x times 3x. And then last times last has to be the last thing. So what times what is negative 4? Negative 2 and positive 2. And that is completely factored. All difference of square pattern here. When you factor difference of squares, it's always a plus b, a minus b. If you like rules, then this is how that works. That's the rule for factoring difference of squares.
I tried my best to say that.
Yeah. You're good. All right. Letter B is a perfect square trinomial. And again, trinomial, what does trinomial mean? 3 terms. Very good. 3 terms. You can see 1, 2, 3 terms. And perfect square trinomials, I think the easiest thing to look for is to say, look at the first and the last term, and they should be perfect squares. So 4x squared is what times what? 2x times 2x. And then 1/9 is what times what? 1/3 times 1/3, or 1/3 squared. So when the first and the last happen to be perfect squares, it's possible it's a perfect square trinomial. But really, I'm always just going to go to my double bubble. Ladies and gentlemen, this is called the double bubble. Do you see the double bubble? Yeah, I much prefer double bubble than factor. But they mean the same thing, okay? So, double bubble, I just like how it sets up a structure for you. We ask ourselves, first times first has to be the first thing. What times what is 4x squared? 2x times 2x. And then last times last has to be the last thing. What times what is 1/9? 1/3 times 1/3. What else?
Positive 9 and 1.
Positive 1/3 times negative 1/3 would be negative 1/9.
1 and 1/9.
Negative 1/3 times negative 1/3 also gives me that positive 1/9. So we have a couple of choices, right? Which one do you want to use? Yeah, use those negatives. Okay, so negative 1/3 and negative 1/3. Now, this is wonderfully factored. I can write this more concisely. How else could I write this? 2x minus 1/3 quantity squared. Very good. I don't care how you write it. Yes, sir.
If you wanted to, could you clear the fractions first?
Okay, yes. So I will talk about that in 1 second. So the only thing I would suggest whenever you're factoring, and you will have some problems that just factoring, they're not patterns. We'll get those tomorrow, I think. Is I'm going to say we checked the first and the last. The first and the last we've already done. So I always tell my students to check the rainbow. Do you see the rainbow? Okay. You always want to check the rainbow to make sure that you get that middle term. So I want to multiply the 2x times the negative 1/3. What do you get? negative 2/3 x. And then if I check the inside of that rainbow, again, negative 1/3 times 2x is
2/3.
negative 2/3 x. And when I put those together, negative 4/3 x, which is our middle term. So we know that we did it correctly. Really important that when you factor, check the rainbow. Okay, double bubble, check the rainbow. That's the best thing. Now, the question was, can I clear the fractions first? So by clearing the fractions, are you asking, can you multiply through by 9? So the question, so can you multiply through by 9?
Yes. Yes.
No. How come I cannot multiply that expression through by 9? I just changed the value. Okay, so the difference, I cannot multiply through by 9 because I can't multiply both sides of an equation, right? Okay, all right. However, your book loves pulling out fractions, and I hate it. So your book does this. They'll take 4x squared minus 4/3 x plus 1/9. And they're going to take that fraction and say, I'm going to go ahead and divide every single term by that 1/9 and pull that 1/9 out in front.
What?
Yeah. What is 4 divided by 1/9? Watch what happens.
Wait, just 36.
36. Yeah, 36x squared. What's 4/3 divided by 1/9?
Oh, no, 36.
How do you do that? Because this is like, whoa, right? Yeah, 4/3 divided by 1/9. What is that? Keep, change, flip? Keep, change, flip? So 4/3 times 9/1 becomes, what's 1/9 divided by 1/9? So your book does this, and then it'll double bubble with a 1/9 out in front. I don't like that. Doesn't it seem harder? Yeah, it's much harder. I don't like that. But your book does that? I don't know. That's just how they do it. Yeah. Okay, ladies and gentlemen, I have one awesome thing for you. If you have your calculator out, which you should, then you're going to want to pay attention. All right, so here we go. All right. Do I have any Casios in the room right now? Yes, I have Casios? Okay. So on the Casio, go to menu, it's menu driven, and you want to be in the graphing menu. Okay? All right. Okay, listen up. This is super duper important. Okay. On my TI, I'm going to be in the y equals menu, and I'm going to go ahead and clear these out so I don't have anything else in my y equals menu. Okay. Now, 90% of mathematics is changing something from one form into another. Equivalent form. These two things are supposed to be equal to one another. We change something into something else to make it easier to use, easier to graph, easier to find the roots of, okay? That's 90% of math. If two things are supposed to be equivalent, what would their graphs be? Their graphs would be the same as well. So, in your calculators, you're going to put in the original expression in y1 and the morphed expression in y2. All right? So, in your calculators, on the Casios, the X button is below the alpha key. All right, so use that X. All right, so we're going to type in 4x squared minus 4/3 x plus 1/9. Over here, I'm going to put it in both. 4x squared minus 4/3 x plus 1/9. And I'm going to also type in the binomial square here. 2x minus 1/3 squared. 2x minus 1/3 squared. Okay, and enter. Now, a couple things I want to point out here on these calculators. You'll notice the equal signs. Are they highlighted? Yes, that means it will graph. Okay? If they aren't highlighted, all right. And then, I'm going to do, on my TI, I'm just going to do a Zoom 6. And on my Casio, I'm just going to, right here is draw. I'm just going to push F6. And it graphs right on top of itself. All right. All right. Watch what happens when I change this 1/3 to just like a 3. All right. And you'll see the original graph, what it's supposed to look like, and then you'll see, oops, we made a mistake. They're not equivalent, okay? So using your graphing calculator to check is a great way to show that two things are equivalent. If their graphs match, so must your expressions, okay? They must be equal. All right. Whatever that means. All right.
Where's the straight line and it has to be just one line?
Their functions. Oh, individually their functions. Yeah. All right, ladies and gentlemen, get started on your homework, please.